Right, very good when you with each other's body out there. Right. So in kinematics, we have three quantities to look at, right? The first quantity is displacement. Right? I'll go over the explanation for displacement. Second, velocity. Anybody here never did physics before or not doing physics? You doing physics? All right. And A is acceleration, right? So I'll have to explain before we go into them, I'll explain it, right? Right? These are all vector quantities, right? Means that every time we talk about them, we have to include it at their direction as well. Okay. So we need to be able to explain each one of these. Right? I'll start with the first one. Right? I'll start with displacement, right? Copy that now. All right. So we have three quantities that we have to look at, and we have to understand each one. As I said, these three quantities are vector quantities. For those who don't know what vector is, a vector must have magnitude and a direction as well. Okay. So when we talk about displacement, right? Displacement definition, straight line distance from start to finish, right? So for example, if I were to say, let's say I had a path like this, right? OAP. And Bob Marley started here, he went here, and he finished here, right? Bob Marley's distance traveled will be here to here plus here to here. Let's use some numbers. 5 meters. Let's say that. Let's use 6 meters, 8 meters, 10 meters. Right? So I want to understand what is displacement. Displacement, for those who are not doing physics, write this down. This is straight line distance. Everybody should write it down. That's someone is going on never yet. Straight line distance from start to finish. Straight line distance. Straight line distance. I don't know, my school. How about you sick? I didn't get you, man. Straight line distance from start to finish. Right? Straight line distance from where you start to where you finish. Right? Right? So for example, if we start at O and we finish at B traveling this way, your distance traveled is 6 plus 4, 6 plus 8, 14. But the displacement from where you start to where you finish is 10 meters. You okay with that? Nathan? Right? So you're starting at O, you go into A, and then you go into B. The total distance traveled is 14 meters. Right? But the displacement is a straight line distance from where you start to where you finish. That straight line distance is 10. So your displacement is 10 meters. Is that okay with that? Right. Sometimes there are questions that kind of look like this, right? So you start a race here and you run the race, right? Or is it a kind of lap, right? So you run to A and then you reach back at O. What's the displacement there? What's the displacement in an example like this? You start at O, you went to A, and then you went back to O. 0. Right? The displacement is 0. Because you start and finish at the same point. That's okay? Right. You're going to have to pay attention to one more thing when it comes to displacement. All of the displacement values on this side is a positive. But if by chance you run here, and then you go behind the starting point, the displacement values are negative. Okay? So it's important to remember that. And again, this sign, positive or negative, tells you where displacement is. If it's on the positive side or on the negative side. That's okay? So if I say negative 2 meters, it means it's somewhere on this side. Okay? So we have to look out for the sign. All right? So let's make a note of these two things here on displacement, please. Example 1 and example 2. Make a quick little note. Right? Kinematics questions. Some of them do have nothing to do with the question or integration. It just put it out with simple calculations like this. Right? So we'll do both types. Right? Walking graph paper next week, right? Some good time graphs, we have some small calculations to do. And you need to just draw them. I can do the time graphs fast today. We did the stats last year, December. December, yes. Form 5, first one. No, I mean form 4, first one. We didn't do stats. Have a little handout and stuff. I'll have a quick look and get to see how to do it. That's right. All right, so these are the things that we need to understand displacement. Next is velocity. Right? Finish. Next, velocity. The velocity of an object. The velocity of an object online. You all okay? Narayan, you okay there? You're good? Nice. So next, velocity. The velocity of an object is the rate of change of displacement. The velocity of an object is the rate of change of displacement. Right? I forgot to give you the SI unit here, but you should know it. Right? Rate of change of displacement. Right. Let's see who remembers some differentiation. How to write that? How to write rate of change of displacement. Very good. Very good. ds dt. I see reading number here, real smart. Right? So it's ds dt, right? This means rate of change of displacement. All right. So what does this show you here, Jeremy? How do I get velocity? Okay, all right, yeah. So the formula, yes. The formula is displacement over time. Right? Right? That's what it implies, right? But how do I get velocity? I wanted to see something here. What this is? I'm telling him on the wrong thing. That's differentiation, but what is differentiating? Displacement. So if I give you displacement and I differentiate it, what you'll get? Velocity. That's enough. So that's the link between displacement and velocity. Okay. Suppose I give you velocity, right? And I say find displacement. What would you do? Integrate. So you'll see the link, right? Very good. Right. That's one thing. The next thing, because of vector quantity, remember the difference in signs. Positive means they're going in one direction. Negative means they're moving in a different direction. Right? So for velocity, your signs represent direction of motion. Okay? Copy it down. Copy it down there. So velocity, the signs represent a change in direction of motion, right? If you're going in one direction, that's positive. If you change direction, it's now negative. Right? And make a note of the SI unit, right? MS minus 1. Barrow. Barrow awaken. I say is sleep away and saying no. Barrow. Sebastian, we wake up I say again from an update. Barrow there. And the man saying answers to what is that? Barrow's an answer somewhere here. That's correct. See? Alan Barrow. Right. So what you say now? Last thing. Oh, you already SI unit, right? Last thing, acceleration. Acceleration is rate of change of velocity. Right? So write that down. Acceleration, rate of change of velocity. Yeah, you know, see it. Yeah, but you're not even watching the man replying. All right. Put the pick on there now. Yeah, come one time. Brema is Brema, right? Pronounce the name right? Brema. Yeah, too bad. You'll call it Brema. I'll call it Brema from now on. Brema, acceleration as well. If you read it over, rate of change of velocity. So how do I write that? This is rate of change of displacement. So what is rate of change of velocity? Right? dv dt. Right? And you would recognize that it's change in velocity, so it's v minus u on t. V and u are v final velocity, and u is initial velocity. Right? And of course, t is time. So Isaiah, see here. All right. Tell him we can still log in and have Wi-Fi then. Huh? Michael. All right, so there's the acceleration, and the sign is really a little bit different here. A positive value means acceleration, and a negative value, regardless of the sign, regardless of the direction, means deceleration. Right, so taking off direction. So positive means acceleration, and negative value means the object is undergoing a deceleration. All right, SI unit, ms minus. On the 26th of October, I think that's a Saturday. Yeah, Saturday. Right, on that Saturday, so we were wrapping up this next week. We'll give you all a worksheet next Saturday on the work on it. So when it comes Saturday, all we do it. That's not come back to worksheet. All right. I'm not sure where, if hopefully you all should be done on the LMS by then in your subjects, so you might put the answers in there. So you work it out. When you work it out, you will get 5, 6, or 7 some value, and you put it in the LMS, and it will correct. All right. How we doing it here? Okay. We got 4 months. Okay. Right. So these are the 3 things that we're looking at, right? Right. And the link between them. If I give you displacement, you differentiate, you're going to get velocity. You differentiate velocity, you're going to get acceleration. And as Kai said, if you integrate this, you get this, integrate this, you get this. So there's a link between 3 of them. And that's the reason why we write them like this. So for me to get velocity, we differentiate. For me to get acceleration, we differentiate. For me to get velocity, we integrate with respect to t. For me to get displacement, we integrate velocity with respect to t. So the link between these 3 quantities is differentiation going down, integration going up. That's okay? So once you write SBA, differentiation going down, integration going upward. Right? Yeah, I get that. Right. Copy it up. And we're gonna try some small pressure and balance. Right? We still have time graphs to look at, but as I said, we'll do that next week, right? So work with some graph paper. I'll also show you the equations of motion and things because sometimes they might be. Ready? All right. There are some small things that we need to understand underneath this. So I want to write note that. Right? There's some small things I want to understand, right? Well, note that number one, instantaneous rest. Note that instantaneous rest, instant, and then continuous after. Instantaneous rest occurs when what? Anybody can guess? Time. 001 time. Okay. But what does instantaneous rest mean? Okay. What does instantaneous rest mean? It means that it's not moving, right? So right at instantaneous rest, velocity is zero. V is equal to zero. When velocity is zero. Instantaneous rest occurs when V is zero. So it means that the object is not moving anymore. Right? Next one, maximum velocity occurs when? Maximum velocity occurs when? Acceleration reaches zero. It means that you reach a max velocity and you're no longer accelerating. Maximum velocity occurs when acceleration is zero. Right, one more. One more. One more. At maximum height. At maximum height. So when an object reaches its maximum height, something happens. At maximum height, what has happened? Is it moving at the maximum height? No, it stops. The velocity is zero. So at maximum height, velocity is zero. Okay? At maximum height, velocity is zero. All right, nice. So we're gonna try some questions on this, right? You will have to figure out what direction you're going in, right? You will have to figure out if you're differentiating or if you're integrating. That's okay? Number one. Right, we'll do each part, we'll do it piece by piece, right? So these questions come with it like this. For a particle, moving in a straight line, for a particle moving in a straight line, and you'll recognize all of our questions have to do with things moving in a straight line, right? For a particle moving in a straight line, its displacement S. Its displacement S. For a particle moving in a straight line, its displacement S. From a point O, its displacement S. From a point O, on a line is given by, on a line is given by S is equal to t squared minus 5t plus 5 plus 6 plus 6. T squared minus 5t plus 6. Right? Where t is in seconds. Where t is in seconds. Right? S is equal to t squared minus 5t plus 6. Where t is time in seconds. Find part A. Find part A, the initial distance. Part A, the initial distance of the particle from O. Right? They want the initial distance of the particle from O. That's the equation they gave us. Right? How do we find the initial distance? This is displacement. So how you would find the initial displacement at O? Remember the particle starts at O, right? So at O, what do we know about T? T is what? 0, because it now starts, right? T is 0. So all we have to do is put T is 0 in there and we get the distance. 0 squared minus 0 plus 6. So that's 6 meters. Okay with that? That's it. All right? That's all. No differentiation, no integration. This gives us displacement, but they want the distance at O. All we have to do is plug in T as 0 and find it. Next one. Verbatim. Next one they want us to find is initial velocity. Right? Can we find initial velocity from this? Can we? Okay. What we have to do first? This equation is displacement. So if they want us to find velocity, what do? We have displacement. So you're going down, we differentiate, right? So in order for us to get an equation with velocity, we have to differentiate, right? We differentiate s with respect to t. That's okay? Right? So let's differentiate this together. Well, what's the differential of t squared? 2t, right? What's the differential of minus 5t? Minus 5. What's the differential of 6? So now, how do I find initial? Initial means at the beginning, right? So what do? Substitute t is 0, right? And we get in v is equal to minus 5 meters per second. What does the minus 5, what does the minus indicate? It's going back, going in the opposite direction. All right, online, you're okay with EMVs so far? We're as your own stuff. Yeah, you're all okay so far? All right, nice. Try part C. Right? At instantaneous rest. Well, when does that happen? When v is 0. So this occurs when v is 0. So what do? We take this and we let v be 0. So it means that 0 is equal to 2t minus 5 t is equal to 5/2 seconds. So this is 2.5 seconds. That okay with that? Everybody okay with that? Right? So it's important that we remember these little things, right?
Yes, boy.
Who's that? Last part, find the acceleration. Last part, find the acceleration. Yeah, Jeremy, finish already? So Jeremy, how is the acceleration? How is the acceleration? Differentiate move what? Velocity. So since you suggest the differentiate velocity, do it from now. What's the differential of 2t minus 5? 2. Oh, that's into this differentiation thing. Are you done? That's the acceleration, 2 meters per second squared. That's all. Alright? Let's go again. How I can enjoy it. And I'm gonna give you one more easy one. Let's stay enjoy it. Yeah. Huh? No. Alright. So I just changed the equation there for you just to get some practice. I want you to find the same things. Find the same things, Summer, please. Try that quick. Oh yeah. Try that definitely. Okay. Oh yeah. Yeah, we done? I need like that. Oh, yeah, super nice again. Right. No, right. 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 See that? See that? Yeah, next sheet. Samir. All right, let's see on this one. So I'll make it a little bit harder. Initial distance T is 0, right? Initial distance T is 0. So all we have to do is put T is 0 in here, right? And you get in 5 meters. Initial velocity, we differentiate here. So that's 60 minus 4. And when T is 0, we have initial. Put T is 0. So you get minus 4 meters per second. Instantaneous rest means that your velocity is 0. So 0 is equal to 60 minus 4. T is equal to 4/6 seconds, or you can write 0.67, right? Acceleration, we just differentiate this and you'll get 6 meters per second. Great. Yeah, let's go again. One more is one. I like given that S is equal to right, given that S is equal to, all right, now it's a little harder to differentiate. Given that S is equal to 2t squared, 2t squared minus t cube on 6. Right, before I even move on, right? How can make this look nicer? But I will change here as well. Can I, instead of writing t cube on 6, just write 16 t cube? Yeah, and this will be easier to differentiate. Bring down the power and so on. Right, so then you have it for doing those little things, right? Number part A. Part A, find the initial velocity and acceleration. Find the initial velocity and acceleration. Find initial velocity and acceleration. One time. Take your time and differentiate this, right? Find the initial velocity and the initial acceleration. Right? Try and figure out what direction they're moving in. Initial velocity and initial acceleration. Take your time. Of course, you have to remember how to. What we're doing for those party differentiation, right? So you have to remember how to differentiate that. Have fun. How is differentiate? How is differentiate? What the differential of 2t squared? Right, so the first part is to find initial velocity. That's the first part. And then they want us to find initial acceleration. Sometimes it's a little more challenging to find the equation, right? Because you have a little more differentiation to do. Right? What's the differentiation? What's the differential of 2t squared? 4t. What's the differential of 16t cubed? Very good. But they want initial, so it means that t is what? So initial velocity is also 0. That's okay? When you put 0 here and here, you'll get 0. Right? Now do the same thing for acceleration, please. Hurry up. Oh yeah. Okay. What's the differential of this? Sorry, this. By the way, what shall we differentiate? S or B to get E? We differentiate V, right? We differentiate V to get E. Okay? What's the differential of this? Differential of 4t is? What's the differential of minus a half t squared? Right. 2 by a half, which is 1. And t, and a minus 1 for the power. 4 minus t. Okay? Bring down the power. 2 over 2 is 1, and minus 1 from the power. Okay. And when t is 0, a is equal to 4 meters per second squared. That's okay? Yeah? Let's go again. Next one. The time, take a time with this one. This is part B. The time after the start. The time after the start when it comes to a momentary halt. That's good, it's funny, right? The time after the start when it comes to a momentary halt. What does that mean? Momentary halt means what? It stops. It means instantaneous rest. Right? So go back and see what happens at instantaneous rest. Right? Before you reply to your phone, your message, your them before you do that. Right? Try and see. Take it look. Oh yeah, we'll start off much faster. Right? Read it again. Right? Find the time after the start when it comes to a momentary halt. So you want to find when velocity is 0. So you want to find the times when v is 0 after it starts. So after it starts, think about it. I'll help with us now. So we know that momentary rest, right? Instantaneous rest, v is equal to 0. See if you can find the times that this happens at. It happens at that. Oh yeah, so that's the one. Right, so when v is 0, they want us to find the times, right? So basically, we have to take 4t minus a half t squared and make it equal to 0. And we have to solve that. What type of equation is this? Quadratic. Solve it fast. You can do it mentally, yeah? Right? It equal to 0, you can factorize and solve. Right? Yeah. Factor out 2. Yeah. Just for factor. But you can factor out here. What's it good? If you do like the fraction, you can multiply by a problem. Make it look easier. And then factorize it. Because it equals to 0, you can multiply everything by 2. Make it look nicer. And then factorize. And then solve it. Or you can use a calculator. But try and factorize it. No. Try and factorize it. Right? So if you want to make it look nice, we can multiply by 2. You'll get 8t minus t squared is 0. And what you can factor out here? T, You could factor t and you'll get 8 minus t is 0. Right? And now, because a product equal to 0, I could say t is 0 and I could say 8 minus t is 0. Remember that? If a product is 0, then one of the products could be 0. One of the factors could be 0. So my two answers are t is 0, but it told me the time after that. T is 8. So when the t is 8 seconds, the particle is instantaneously at rest. That's okay? And also at the beginning is at rest. And we know that already. We know that when t is 0, b is 0. All right? Let's try one more part. Then I'll give you a break up the next week. Yeah, the correct the component, right? Last part. Take your time with this part, right? What is the maximum velocity of the particle? What is the maximum velocity of the particle? This one a little bit tricky. What is the maximum velocity of the particle? Take your time, right? What is the maximum velocity of the particle? This is the last one. Remember to work the graph paper next week, right? What is the maximum velocity of the particle? So I gave you a small note. That says, right, maximum velocity occurs when the acceleration is 0. Right? So when a is 0, what do we know? Guys, when a is 0, what do we know? Right? But what else do we know? What's it good then? What's the equation for A? A is equal to 4 minus t. Online, you're okay, right? Right, so this is the last one we do it. Yeah. When A is 0, what do we know? Watch it good. Put A is 0 in there and see what happens. What you get? P equal to 4. So when A is equal to 0, the time is equal to 4 seconds. Is that the answer? No. What the question asks? What is the maximum velocity? What do we find here? We find it when it occurs. So how do I get the max velocity? Plug this into the one with B. See that? See the length? So this is the time when maximum velocity happens. So how do we get velocity? We have to go back to the equation that gives us velocity. Okay. All right, so V is equal to 4t minus a half t squared. So that's 4 by 4 minus a half by 4 squared. 8. Yeah. That is your maximum velocity. All right. All right. So that is the intro to kinematics. Next day, we continuing. This is the most important thing, right? Next day, we continue with some harder ones, but you recognize that only did differentiation today. I will try to give it some the other way around. Okay? But please remember this for next week. And the week after is when I'll give you the worksheet, right? I'll give you the opposite one.